Here we go. Already time for the Unit 2 test. Um, this one was all about graphing angles on a coordinate plane. So first things first, want to draw each angle in the standard position. So remember, when we talk about standard position, um, if we have a coordinate graph or a coordinate grid, whatever you want to call it, um, the standard position is we're always going to start on the positive x-axis. This was our initial side. All right, and that one stays put. It will always be on the positive x-axis. And then we have the other one. This was our terminal side. All right, so this is kind of where the angle terminates or where it stops. And in math, a counterclockwise angle is a positive angle. All right, so this one will be positive. A clockwise angle is negative. All right, just a negative number. So now that that's out of the way, let's go back to it here. Draw each angle in standard position, then give its reference angle in degrees. So if we were to draw this first one, so 157, I don't know exactly where 157 is, but I know it's smaller than 180 and it's bigger than 90, right? And it's closer to 180 than it is 90. So if we want to just kind of label the important parts on this, we have a 90, we have a 180, we have a 270. And then this one you could call 0 or even 360, right? A full spin is 360 degrees. So if we're looking for a 157 degree angle, that is going to be about right here. So this is 157. Now the reference angle always connects to the closest x-axis. So in this case, it will be this angle right here. How much is it going to take to get to 180? So all you have to do is just 180 minus 157, and that will give you 23. So that is a 23 degree reference angle. Right. The next one, 314. So again, not quite 360. So maybe that'll be somewhere right here. So this is a 314 degree angle. Since it's positive, here, let's do this. Right here's our starting side. And since it's positive, we are going to go counterclockwise. All right, we're trying to get back to the x-axis here. So this is a 360 degree rotation. So to figure out the reference angle, 360 minus 314. All right, and I believe that is 46. All right, so the reference angle here is 46. All right, now the next one, 195. So remember, that's going to be a clockwise angle. So starting out in the beginning, 195, negative 195, that's a little bit bigger than negative 180. Right? So it'll look something like this. All right. So we're at negative 195. We need to get back to negative 180. So just think, okay, how far apart are those? 195 and 180 are 15 degrees apart. Now a reference angle is always positive. I didn't mention this before. Right? But it doesn't matter if we have positive angles or negative angles. That reference angle will always, always, always be a positive number. Right? So now on these, they want us to draw, very similar, draw in standard position and name the quadrant. So remember the quadrants, again, go counterclockwise, 1, 2, 3, and 4. So we use Roman numerals to number these things. So that's just what our quadrants look like. All right. They want us to give a reference angle, which is what we just did. They want us to name a larger and smaller what? So this I'm going to assume is coterminal. Coterminal angle. We'll do that in a bit. And then the supplement and complement. So remember, supplementary angles add up to 180. Complementary angles have to add up to 90. All right. So if we kind of scroll down below, it'll have us go one by one. So starting off, drawing it in standard position, we're going to start off positive x-axis in get up to 122. So that's going to be more or less right here. This is a 122-degree angle. It's a positive angle. Okay. So they want us to name the reference angle. That's going to be what it takes to get us down to 180. So we just got to think, all right, 180 minus 122. That should be 58. So we have a reference angle of 58 degrees. So let's just go ahead and fill all of that out. What quadrant is this in? So this quadrant right here, this is the second quadrant. All right, sorry about that. Let's see here. So that's quadrant 2 there. So what quadrant are we in? We are in quadrant 2. All right. The reference angle we found, that is 58. Now, what do they want next? A larger coterminal angle. All right. Don't overcomplicate this one. To figure out a larger coterminal angle, take the angle we have and just add 360 to it. All right. So we had a 122-degree angle. Just add 360. All right. So that gives us, I don't know, 482. All right. So a coterminal angle, what that means is we mentioned how this is the terminal side right here. So if I just take this angle and keep going, right? If I hit this angle and I pass through it and I keep spinning, it's going to end at that same spot. So that is a larger coterminal angle. Now, the other one says a smaller coterminal angle. So what we have to do here is just take our angle, 122, and subtract 360. All right, so that should give us I want to say 238. Right. You might have to double check me on that, but I think it's 238. So what that means is, starting at the initial side, all we're doing is we're just going clockwise. All right, so we are making a negative angle, and it still hits that same terminal side. All right, so the larger coterminal angle is 482, and then the smaller one is 238. All right, so you can add 360 again and again and again, keep spinning around. But if they just want, the next larger one is fine. All right. So now the complement, right? A complementary angle are going to be two angles that add up to 90 degrees. All right. So let's just think of it like this. I have some angle, right? I don't know what that angle is. I'm just going to call it X. X plus the original angle that I had, which in this case was 122. All right. If I add those two things together, I need to get a 90-degree angle. All right. So what is the value of X? All we're doing is just one-step algebra problem, and we're going to have X equals negative 32. Right? Negative 32 plus 90, I'm sorry, negative 32 plus 122 gives you 90, right? So we have a negative 32-degree angle. Now the supplement, same exact process. We're going to have Y plus 122. Right? Now in this case, supplementary angles have to add up to 180. Right? So subtract your 122, we're going to get Y equals 58 in this case. All right, so notice how the reference angle and the supplement, they're the same number. That is not always going to happen, right? That's just purely a coincidence in this case. So don't think that's always going to be true. Sometimes it works. I would argue most times it does not. All right, so don't think that those are always going to be the same thing. All right, next one. 35.5 degrees, 35.5 degrees. What do we have? That's going to be somewhere right here. So this is our angle in our standard position. Here is 35.5. All right, this is in quadrant 1. All right, so quadrant 1. The nice thing about anything that's in quadrant 1 is the angle itself is always going to be the same thing as the reference angle. So the reference angle here is 35.5 because we're just trying to get back to the closest x-axis. And the closest x-axis is just where we started. All right, a larger coterminal angle. So again, we're going to start at 0, and we're going to go all the way around I'm going to end at the same spot. So that's just going to be 35.5 plus 360. That is going to be 395.5. Right? Smaller coterminal angle. We're going backwards. We're just spinning around backwards. So 35.5 minus 360. That will be a negative number. What is that negative number? I don't know. 324.5. Again, double check me on that, but I think it's 324.5. All right. Complement. So same process. We'll try to keep my colors the same here. X plus 35.5. Add those together, it equals 90. All right. Solve for X. We're gonna have X equals, that should be 54.5. All right. And the supplement, same thing. Doesn't matter what letter you use. You can reuse an X if you want. Y plus 35.5 equals 180. Y equals 144.5. And there we go. That is page 1 of your Unit 2 test. All right, that kind of pretty much covered all of section 0.1. So, section 1. All right, so there it is. We'll see you in the next one.